So we are going to work through these practice problems here. Let's see. So for the first one, we're going to use the sum law, which is going to let me break the limit up across the addition, and the constant multiple law, which will let me push the 2 out front. So I'll get 2 limit x approaches -3 of x plus limit as x approaches -3 of 5. Now, limit as x approaches -3 of x itself is -3. And then limit as x approaches -3 of a constant 5 is just 5. So this is -6 plus 5, which is 1. For this one, I'm going to use the quotient law to get started. So that'll let this be limit as x approaches 5 of the top over limit as x approaches 5 of the bottom. Then I can use the sum law to break this up. So it'll be limit as x approaches 5 of x minus limit x approaches 5 of 3 over limit as x approaches 5 of x plus limit x approaches 5 of 5. Limit as x approaches 5 of x is 5 minus limit as x approaches 5 of 3 is 3 over limit as x approaches 5 of x is 5 plus limit as x approaches 5 of 5 is 5. I get 2 over 10, which is 1 over 5. Okay, since we're looking at the value 7 here for absolute value, let's see here. So we're basically, for this one, we're going to let x get very close to 7. So we'll kind of think about this. As x gets very close to 7, something very close to 7 minus 12 will get very close to -5. So that'll be limit as x, well, I guess we could just say that'll be very close to absolute value of -5, which will become +5. Because as x approaches 7, 7 minus 12 is -5, and that becomes +5. For this one, we're able to pull the limit inside, the square root. Then we can break the limit up across that. Subtraction, so we'll get limit x approaches 2 of x minus limit x approaches 2 of 5. Limit as x approaches 2 of x is just 2, minus limit as x approaches 2 of 5 is 5. So we get square root of a negative, which this does not exist. Actually, I shouldn't have pulled this in here because this was going to lead to a square root of a negative. So this one can't do that because the limit doesn't exist. Let's see here. Over here, x is approaching a -4, so we're just going to kind of pull the limit on inside there. X approaches -4. -4 plus 2 approaches -2. So we get this is approaching -2 squared, and then that's becoming 4. And out here, we're going to break the limit across the individual pieces. Then we're going to pull the limit inside the square, and here we'll push the 5 out front. So we'll get 2 times limit x approaches 0 of x whole bit squared. And I should have said, like this one I accidentally worked a little fast. I should have said the limit pulled inside the square and then broke across the addition. But over here, let's see here, we're going to push the 5 out front. We're using constant multiple basic law there. Limit as x approaches 0 of a constant 3 is just a constant 3 back. Limit as x approaches 0 of x, that's 0. -5 times limit as x approaches 0 of x is 0. So we get basically 0 minus 0 plus 3, which is 3. So that is those. Let's take a look at the next grouping. Okay. Use limit laws to figure this thing out. So we're going to pull the limit inside the square root first. So we'll get limit x approaches 3 of f of x, h of x, minus x squared g of x. Okay, then I'm going to split the limit across the subtraction, and I'm going to use the product rule of the limits to break this up. And I'll get equals square root of limit x approaches 3 of f of x times limit x approaches 3 h of x minus limit x approaches 3 of x squared, and then I can pull the limit inside the square and write it that way, and then limit x approaches 3 of g of x. Okay, now they told us some of these numbers, so let's try to plug those in. X approaches 3 of f of x approaches 3 of f of x is 2, times the limit as h approaches, or x approaches 3 of h of x is 3, minus the limit as x approaches 3 of x is 3, and then the 3 gets squared, times limit as x approaches 3 of g of x, that is negative 1. So this becomes 6 minus 9 times negative 1, which minus a negative is positive. So it becomes 6 plus 9, which equals the square root of 15. Okay. All right, so next we want to evaluate this thing using the limit laws. So I'm going to do a lot of steps at once. I'm going to split this across the top and the bottom, break it across the additions, push the constant multiples out front, and pull it inside the powers. So we'll get limit as x approaches 2 of x squared with the constant multiple 2 pushed out front, plus limit x approaches 2 of 1. All that over, it's going to be the limit as x approaches 2 of x squared, plus the constant 6 will be out front, limit as x approaches 2 of x, minus limit as x approaches 2 of 4. So limit as x approaches 2 is 2. That gets squared. Plus limit as x approaches 2 of the constant 1 is 1. All that over, limit as x approaches 2 of x, which is 2, and it gets squared. 6 times the limit as x approaches 2 of x, so that's plus 6 times 2, minus limit as x approaches 2 of 4, so that's minus 4. So let's see here, 4 times 2 is 8, plus 1 is 9, over 4 plus, or I guess 4 minus 4 cancel, 6 times 2 is 12, and then we can divide these by 3 and get 3 over 4. Okay, and then this final one, we can split it up and get it as 2 times limit x approaches 1 squared plus 3 times limit x approaches 1 of x minus limit as x approaches 1 of 5. So this will be 2 times 1 squared plus 3 times 1 minus 5, which will be 2 plus 3 minus 5. So that's 5 minus 5 is 0. Okay, so that should do it for our practice problems. Should be good.